Hi, I'm Charlotte Dungan. I am the AI program architect at the North Carolina School of Science and Math. The exciting thing about what we're doing right now is we're helping schools integrate the new North Carolina computer science standards, and we focus on doing that with artificial intelligence. You can learn more about my initiatives at a really cool new website that we've just designed for teachers in North Carolina and beyond, called aiforteachers.org. Now let's see if we can get this screen sharing going. Here it is, aiforteachers.org. This is the place where you can find and learn about all different types of AI resources for your K-5 classroom. We have tools for learning, a discussion space, teaching resources, and professional development. I'd like to show you our professional development first because it's a great place to get started if you don't know much about AI. This module right here, called Intro to AI Module 1, is the place where you can choose a self-paced course, enroll, and then learn all about how it's actually a playing game. You play a day in the life of a teacher, and you learn where AI is in our society. So upon completion of the course, you'll be able to describe what artificial intelligence is, including what might happen in the future. You'll know where AI is found in everyday life and how it connects to college and career for students. You'll be able to think about AI technologies ethically and to attempt to mitigate bias in those technologies. And you'll learn about the 5 big ideas in AI. Now we're going to talk about those a little bit more in this webinar, but the PD will go a little bit more in depth. And then we'll provide resources and content that can be used in the classroom for the AI standards. You can also help students who have some familiarity with coding to include AI in their coding. And yes, I'm talking about 4th graders. Kids who are comfortable with Scratch can absolutely use AI. So we're going to flip back and forth between me talking and me screen sharing. This is my first sort of virtual conference, so forgive me if you have any troubles, but I would like to encourage you that you can write to me, Charlotte, CHARLOTTE, at aiforteachers.org with any questions or follow-up that you have. You can also write at the website AI for Teachers, and we would be happy to support you. The goal of AI for Teachers is to support teachers in integrating technology within their courses. So we don't want you to add a whole new class. We think that these lessons are really applicable in the stuff that you're already teaching. So let's get started with our first resource. I want to go through just a moment and talk about the AI for K-12 standards, guidelines that are being developed. I'm a part of the AI for K-12 working group. I worked on the K-2 grade band standards, and then for my second year, I actually worked on 6 to 8. So this is the time to begin teaching AI in K-12 because we're also rolling out in the state the computer science standards. So it's a really great time to integrate AI. We'll talk here about, this is the presentation from AI for K-12. I have permission to use it, and I just wanted to share why should we be teaching AI? And that's because the technology is already all around us. There was sort of a revolution when computers came out. They began appearing in workplaces and then eventually in the home. Very obvious, big box on your desk. You moved from paper-based to computing-based implementations of using technology, right? Instead of paying the bill in the mail, you probably pay it online, or you file your taxes online instead of mailing them in. The same thing happened with your phone. Your phone became the Star Trek communicator. You can now do many more things other than call people using apps, listening to music, watching a video. We're always plugged in now. And those shifts in society were very obvious because you had a new device right there in your hand. AI is just as transformative in our society, but it's invisible. So most people don't know about it. And that's not just, the examples here are like, Alexa and Google, self-driving cars and autonomous robots. I do have a vacuum that vacuums my floor using AI, and I do use Google Home to set an alarm or help me to cook, those kinds of things. But I think that technology is actually being used in ways in our financial markets, in tracking in your stores, and those types of areas that affect how much you pay for insurance, who can get a home loan. and who's sentenced and for how long in our criminal justice system. And so those larger societal impacts are really important for people to understand how much AI is actually doing to transform our lives. It is what caused us to have more biased news over this last election cycle. Like, everybody sees more polarized information. We don't actually see the same news anymore. And then the whole electorate becomes more polarized. So with these disruptions, we also see that job loss is coming in certain areas. Jobs that we thought were really protected may not be. And so we do think that there's a growing need for AI literate workers, and students should be encouraged from a young age to consider STEM careers. However, in the STEM career field, only technology, only computer science has a vast number of openings of jobs. So we need scientists, we need engineers, we need mathematicians, but we have about the right number of them, actually. Once we encourage people to go into those fields, they do. There's about the right number of those professions. But computer science is actually, we're missing about 70% of the people that we could hire if people took that as a major and had it become a career field. So as much as you teach science, please add computer science, because it's fun and it is in every other aspect of what we do. If a student grows up and does marketing, if a student grows up and does healthcare, they're going to use computer science in that job. So we think virtually everyone will need a basic understanding of technologies that underpin machine learning and artificial intelligence. And that should be for everyone, right? This shouldn't be limited to boys or kids in urban areas who have a lot of access to resources. Shouldn't mean that you need to look a certain way. This is for everyone. So the national guidelines are being created by AI for K-12, and they sit right alongside the computer science standards in the same grade bands. And so this was funded by the National Science Foundation, I should say that. Here's the steering committee. They're lovely people. And I'm in this photo. If you look at the very back, I'm back there. And we're just going to scroll down here so that I can show you the standards that currently exist. You'll notice there's only standards in the computer science teaching standards for 11th and 12th grade. However, in North Carolina, we have AI guidelines, guiding principles that reach K to 12. And here you can see the 5 big ideas that are in AI and how and I'll give you examples of how those can be used in a K to 5 classroom. The first big idea is this circle right here. This is what we're talking about. Here you go, is that computers perceive the world using sensors. So sensors and perception is the first big idea. And a great example of this, I'm going to take you to, is at Teachable Machine, teachablemachine.withgoogle.com. And we can do an image, audio, or pose project, but image I like, it's a good one. We can call this class Coffee. And you can imagine doing this in a classroom, right, with a type of material. You can do this virtually too. You can have students find different types of material. And so here I have a coffee cup. I brought one just for you today. Inspire, motivate, teach, love, spark. And I'm just going to add image samples from the webcam. I'm going to hold this button to record that this object in this picture is a coffee cup. And I'm going to take this me out of it, and I'm going to make sure I show it without the handle, and maybe I'll show it with the circle part. And now I've got 200 images that I've just taken of what this coffee cup might look like. Now I'm going to make a second class, and I'm going to call it Notebook. And this one is encouraging you to do something creative every day. Here I'm going to make some pictures of the notebook. Maybe I'll get the edges of it. So now I've got, oh no, I put them in the wrong one. Boy, that isn't going to work, is it? Oh, I made a mistake. So let's just delete that and we'll start over. Remove all the samples. Gosh, not a great demo, eh? I'm really sorry. Let's try that again. So here we are with the coffee. Okay. This time I only took 62. And now let's push the right button and hold to record the notebook. Great. And now we're going to add a third class that is for nothing. And this gives us a class that shows that we don't want me to be the thing that the model learns is a coffee cup or a notebook, because I'm in these other photos. So now we're training the model, and you can imagine doing this in a sensory lesson. So let's say that you're talking about healthy foods and the characteristics to sort them, and you have green beans and broccoli and all kinds of other, lettuce and that kind of thing, and then you've got like M&Ms and Reese's peanut butter cups and ice cream, and then you bring up a green gummy bear. And where do you think that this model would put that gummy bear? I think it would probably put it in the green category, right? The vegetable category. So we can talk about how AI systems, they sense something by using a camera. And this is showing that this knows that this is the notebook. You can see that coming up. But it's not smart, right? Like, just because it sensed that this is a coffee cup doesn't mean it knows what coffee is. What happens if I show it this? It's not sure if it's nothing or coffee. Different cup. If it's white, it's thinking, oh, maybe, I'm not sure. What if we show it something like my phone? Similar color, close to a notebook, right? It's not perfect, but pretty close to the notebook color. So you can see how it starts to categorize things. This is a great thing to do with students with Teachable Machine, to talk about how sensors might be used. Got another example for you here. I need to stop sharing for just a second to pull it up. And what it does is it allows you to show how sensors can be extended beyond our regular human senses. And if you're talking about sensors and perception with students, you might talk about the 5 senses and then add a 6th and a 7th sense, so that we have both proprioception, that we know where our bodies are in space, and we have the vestibular system. We know how to balance. Those things are both things that we need AI systems to overcome. Okay, I'm going to show you one other sensor activity that you can do with students. This is from the National Radio Astronomy Observatory, and these are pictures that have been taken by computers, and you can turn on and off the different types of cameras that are available to view this Crab Nebula. So we've got a radio perception, we've got infrared, got visible light spectrum. I do think I recall that this particular activity, I'm gonna have to pull it up in a different browser. It doesn't work for me in Chrome. So let me pull it up in Safari super fast. And then we'll share that one with you. Here we are. All right, so here we are with the Crab Nebula, and we can turn on or off these various versions. So this is what the radio telescope shows. This is what infrared shows. I do not know why this stuff isn't loading correctly for me today. I apologize. Normally this website works just great. Please try it. So the URL is up here at the top, National Radio Astronomy Observatory Cosmic Coloring Compositor. And what you can do is turn on and off the various types of sensors and talk about how technology extends our senses. It actually allows us to see further away, to see wavelengths of light that we wouldn't otherwise be able to see. And in the AI, that first concept is sensors and perception. So you can have students learn about sensors and how they compare to our own senses. The next area, the second big idea in AI, is representation and reasoning. And the most common way that people are used to thinking about this might now be a Snapchat. So I'm going to show you a quick video from Snapchat that explains how those filters work and how the representation of your face is how we're able to put some silly things on your body when you're watching using the application. So here it is, how Snapchat filters work. You can search for this on YouTube, and here's the video.
Hey Joss, I have a question for you. Do you know how these Snapchat filters work? Like behind the scenes?
I have no idea.
Well, do you think you could find out?
You got it. These are what Snapchat calls their lenses, but everyone else calls filters. They are very silly, but the engineering behind them is serious. Oh my God. The technology came from a Ukrainian startup called Luxury, which Snapchat acquired in September 2015 for $150 million. That's reportedly the largest tech acquisition in Ukrainian history. Their augmented reality filters tap into the large and rapidly growing field of computer vision. Those are applications that use pixel data from a camera in order to identify objects and interpret 3D space. Computer vision is how you can deposit checks with your phone. It's how Facebook knows who's in your photos, how self-driving cars can avoid running over people, and how you can give yourself a doggy nose.
Okay, so I encourage you to finish this video on your own when we have a little bit more time. It's really fantastic. It talks about the technology used in Snapchat filters and how that representation of your face, how we can perform reasoning to put the doggy ears and the nose and to have the tongue roll out when you stick out your own tongue, how that is an AI application. Now, another way that you can experiment with representation and reasoning is with a really great classroom activity. It is called Quick Draw, quickdraw.withgoogle.com, and I'm going to share that here with you right now. So here's Quick Draw, and first you choose Let's Draw. You have students choose to draw. We're going to draw a line in under 20 seconds, so here we go.
Oh, I know, it's line.
It was a pretty easy one, right? Let's draw a toaster. That's a little bit more challenging.
I see bread, or hat, or pillow, or square. Oh, I know, it's toaster.
Here's a wheel, and you should go play this too. It's super
I see
fun.
circle. I see baseball. Oh, I know, it's wheel.
Okay, a crown.
I see squiggle, or zigzag, or mountain, or grass. Oh, I know, it's crown. I see square, or pillow. Oh, I know, it's shorts.
It used to be harder to get all these right.
I see bench, or square. I see camera, or washing machine. I see power outlet, or cooler. Oh, I know, it's radio.
Okay, so in this case, the AI was able to figure out all of my drawings despite my lack of ability to draw. And if you look at the data set, there's a button right here that says data. It's also on the start of the screen. You can actually see the data sets of all the things that people have drawn. So in this case, one of my favorites is called animal migration. These are in alphabetical order. So let's see if we can find it. There it is, animal migration. And 115,000 people have been given the prompt animal migration, and they have drawn something that they think might be animal migration. We see lots of images of birds here. We see groups of animals together. But what's most interesting is if you mouse over them, you can see how the people drew them. Where did they start? What did they draw? So we can also switch to any other object that you'd like to, like how about a bathtub? And we can see all the different types of bathtubs that people have drawn, in this case, 152,000. And I mentioned earlier that sometimes it used to be harder to get them right, but as people have continued adding data, the computer system is very, very good at guessing now what you happen to be drawing. So if you look and mouse over, you might notice that people often draw things in a similar way. They either start with a circle at the top, or they draw this sort of half circle larger bottom, and you can see that same pattern repeat over and over, and the computer picks up on that type of pattern of how people are drawing, not just the final product, but how they're drawing. That's why when I drew my wheel, it knew as soon as I added a cross line that it was going to be a wheel, that I was going to add the spokes or something like that. It didn't know from the circle shape because so many things start with a circle shape. Like if we were choosing a baseball, the baseball is one of the objects. Here's basketball. All of those things start with circles, so it's hard to know which circle it was. But by the time the AI system sees the cross line, it knows that it's not a baseball, because the baseball lines, for the most part, only go on the sides, which is not how we draw a wheel. So this is a great activity for about ages 2nd grade and up. It's frustrating for the younger guys because they only have 20 seconds. So it's pretty slow. But once you've shown quick draw, you can show auto draw. Auto draw is better for the K-2 set because you can draw without there being a lot of time crunch. So here is a button right here on the left, this black circle. And if we click that, we can draw the same type of thing that we were before. Maybe it's a baseball, like we were just looking at. And as soon as I start to draw something that resembles a circle or a baseball, I start to get all these various options up here. So I wanted a baseball, I can click on it, and it transforms my drawing from what I had drawn, the shaky lines and maybe incomplete, to an actual clip art that I can manipulate, move around. I can select this, I can resize it, I can recolor it, and I can use AI to turn my sketch, which wasn't super great, into a clip art that I can actually use and put in a presentation. This is a great example of quick draw, getting people to submit drawings, and then Google turning this into a product. They turned that drawing data set into something that could be used and sold by people. Isn't that amazing? I think that's such a great progression for students to see how data, a lot of data can be assembled and then turned into a product. So representation is the idea that the computer builds a model of our world. It is not a complete picture. It's certainly just a slice of how our world works, but then based on that model of the representation of the world, it can perform reasoning, and usually pretty good reasoning. You experience this reasoning every single time you use a map to help you navigate, whether it's Waze, Apple Maps, Google Maps. When you have the system take you somewhere and it takes you only on the roads instead of bike paths, or it adapts for you to be taking public transit, those are that's reasoning that's being applied to using an algorithm, an AI algorithm. So our third idea is that computer systems learn from data, a lot of data, lot of data. And one of my favorite things for students to do is actually on something called brilliant.org, and it is called neural nets. And this is how a computer system might learn how to draw. So this is actually neural nets page 7, which is kind of weird, but as long as you get to brilliant.org/practice/neural nets, you can see how a system might guess what number you're choosing. So there it guessed that I was drawing a 0, and here's a 7. But what happens if I draw a small 7? It gets confused. It thinks it's a 1. So we can talk about how adding more data and giving more information might allow the system to get better and better. And one of the examples that I use for this is a YouTube video that is called Mar.io. Mar.io is a Mario game that it's super relatable to kids because they all know video games.
Welcome back, Sethling here.
And
you're watching.
I'll pull it up for you. It shows how a computer system might actually learn how to do something. And here we are. Let's skip a little ways. So here the computer system has learned how to play Super Mario Brothers, and it does it very, very well. And I would like you to show the whole video, but we just don't have enough time to watch it here. It's 6 minutes and it explains it. Just search for Mar.io, and you can see over here on the right are the buttons that a user could press: A, B, X, Y, up, down, left, and right. And this over here, this little box, is the representation of the world. The white boxes being places that the character can stand, and the red line being the character itself, and the black boxes are where an enemy is. So using this representation, doesn't see any of the other pretty things that we see. It doesn't know that Mario is anything except a red line. It uses button presses that you see in green to find ways to make it through successfully in the level. And it ends up playing in a way that's very, very different for us. For example, it spins almost all the time. Mario is always spinning so that if it hits a character, Mario stays alive. It's not getting coins, but what it is trying to do is maximize its score as it gets toward the end. So getting to the end gets a large reward. Getting a high score also gets a large reward. It doesn't even know at the start that you should go right. So it's really impressive to watch this, and as you're talking about evolution in your science classes, this is an amazing, engaging way to talk about and show neural evolution in a computer system. It shows how a system with randomness can actually evolve, and it talks about the evolution of this. You'll notice even that it says that there's a species, there's a genome, there is actually some cross-pollination here. It's great stuff. And you can do this in language arts too, with some of the poetry apps that are out there, some really great writing that AI does that's pretty funny. And so I just wanted to show you that. I'm watching the time, and I don't want to run out of time because we have 2 more things to go through. The next thing, let's see, we've done sensors and perception, representation and reasoning. We know that computers learn through a lot of data, and I would be remiss if I didn't show you the amazing data sets, that some of which do not include AI and some of which do, but codap.concord.org has a really amazing, super kid-friendly interface. This particular game has to do with rock, paper, scissors, and students can actually see the data as they go. So in this case, if I click on rock, it shows over here in real time what turn happened, and I can graph those things over time just by clicking on the graph. I can make different graphs, and I can move different columns into this space, and I can actually change what's graphed right there. And there's a bunch of other data sets too that you can choose from. So if rock, paper, scissors isn't your thing and you want to connect with like seals and how their migratory paths are measured, you can actually see those data points, and you can do the same thing with a completely separate set of data, or students can gather their own data. So if you've done the ant project where you set things outside, this great way of learning from data is really awesome, even if it doesn't directly connect to AI, because AI at the heart is about measurement of data and then prediction from that data. So codap.concord.org is completely free. You can go to the main page there, and I just think it's such a great classroom resource for educators. And there's a whole section for educators that has additional guides, tutorials, classroom resources, and data games. So I really encourage you to explore this website. It's fantastic. It's such a good resource for data. And then the last piece, the great thing that I think all kids become engaged with is like, are our technologies ethical? Do they actually do good in the world? And one of my favorite resources for discussing this with students is MIT's Moral Machine. I think any kid who can read in some capacity will be able to do this. If you're doing it with younger kids, it's probably best for 3 to 5. I don't know that you'd want to bring this into a younger classroom. It's a little bit morbid, but it's about like, what should the self-driving car do? And there's different descriptions, so you can hide the descriptions. And maybe it's always going to drive straight, or maybe it's going to move in different ways. And you can do this like 13 times. I'm just going to click all the way through so that you can see the end. The car is making decisions about which way it should go, given a really tricky situation. And there's all kinds of awesome videos in the professional development I showed you, but also on YouTube about AI cars and how they drive. And so I don't want to do the survey. And then it gives you results at the end. So did I choose whether or not, I was saving myself or others? Do I want to protect passengers? Do I always follow the law? Do I go straight all the time, or do I turn? Did I try to save males or females, humans or pets, etc.? The great thing to talk about here is the first thing is that this is not actually how AI works. AI cars do not differentiate between male and female, between a doctor or a homeless person, between a dog or a child. They always, in every circumstance, try to protect people from being in an accident, right? But cars have to uphold the law. Can you imagine if a company let out a product into the world that was a car that did not uphold the law? Like, it's great to talk about how with kids about how the technology has to uphold the law, right? That if they made other decisions for other reasons, that the law is going to come first. And the second thing is if they protected passengers versus people out on the street, like a car could not be sold that doesn't protect passengers. Ford cannot sell a Ford car if it protects other people instead of the occupants. So there are some biases that are built into the technologies that we build, and they're not going to go away. The fact that a technology has to work for the person who purchases it and that a technology has to follow applicable laws are unlikely to change. And so there are biases built into our technologies, and there are preferences such as gender or types of humans that our systems are biased for or against. And this is just a lovely little way to start discussing those types of ethical issues. Sometimes you can talk about this in terms of your civics lessons or what it means, like given a finite number of resources, like what do we choose to prioritize in terms of climate change or you can really apply it to many, many things, but like given a finite amount of resources, what technologies should we develop? And in this case, self-driving cars, people have a lot of feelings about them, but the reality is they would save hundreds of thousands of lives each year. And the data for that is evident in airplanes, which are almost entirely flown by AI systems. And in some years, there are no crashes at all, no fatalities. And that's because automated systems have a much higher bar. We expect our technologies to work much more than humans are expected to do things perfectly. And we get sleepy, we get distracted, we make poor choices in vehicles, and self-driving cars are going to be a technology that save lives. So we'll have other ethical issues like, can you put your 4-year-old in the car to be driven to daycare on their own? Or what happens when your 13-year-old wants to go to the mall? Then they call up a self-driving car. So it's not that the ethical issues will go away. It's just that some of these things are really great to talk about with kids about, should a 9-year-old be able to go to school in a self-driving car? And how is that different than a school bus? So those are the 5 big ideas in AI. We have sensors and perception. We have representation and reasoning. We have learning from data. We have ethical concerns. And then the 5th one, the last one, is natural interaction. We want our technologies to interface with us so seamlessly that it seems easy, right? Like one area that is not yet completely seamless is translation. Have you guys used Google Translate? There is this fantastic video. It is called The Fresh Prince Translation. It's so great. And it just shows how translation is not there yet. So let me pull that up for you right here. It's just a second. All right. Got to push that share screen button. I'm getting there. Thanks for your patience. Okay, so this is the Fresh Prince Google Translated. I'm going to just show you a minute of it or so. They're singing the Fresh Prince song.
Probably not, because that's ridiculous, and I have no idea why anyone would do that. But that's what we're all about at CBZA. So let's take the lyrics to the song and put it in Google Translate, and we'll translate it to the world's most spoken language, Mandarin Chinese. We'll take the results and then translate it back into English. All right, this is what the song would sound like. Let's do it. 1, 2, 3. Born and raised in West Philadelphia on the playground where I spent my days. Oh, apricot, relaxing on cool. Shoot some beat ball outside of school. When a couple of guys, they do not get better. Start making trouble in my neighborhood. A little afraid to hit me and my mom, she said, I whistled for a cab, and when it came near, fresh on the license plate so good, mirror nice. It could be anything I can say that this cab was there, but I don't think you get it, your home, Ah.
All right, so you can keep going with that. They actually translate through a whole bunch of languages, and it is really hilarious. Students love this. And it's great to talk about the nuances of translation because it just gets so wonky. It gets so weird over time. Gender gets changed, and slight idioms become like really big, egregious problems when translating from language to language. Another way that we interact naturally is through text-to-speech and speech-to-text. And you can talk about when you use autofill and how that doesn't always go well, and like spelling and grammar checkers they're not always accurate. But natural language processing and other types of natural interactions, such as like something recognizing your face and then like talking to you in a human voice, or having a robot do a really good job at moving around in a space. Those are all ways that AI researchers are improving the ways that our technologies interact with us. One really cool application of natural interaction is actually like in robotic limbs, and how they can look really real now and function better for people who have disabilities, because they can interact and interface with them very naturally without a lot of external mechanical support. So there is, I think, translation is probably the easiest thing right there to bring into the classroom. But I do encourage you to continue adding AI to your classroom. Please reach out to me if you'd like to talk more about your specific scenario. Maybe you have a lesson or a unit, or you just want to work in a specific subject like math, or it doesn't have to be math. Like, give me that social studies. We'd love to talk to you about that. We are working on an AI for teachers. We have some resources. I'm just going to do one more thing. I didn't plan this, but I definitely just want to show you some things that can bring it back to your classroom. Let me just go over there real quick, and then I'll sign off. So, oh, maybe I shouldn't have done this. Let's see. So we've got some teaching resources over here. Here we are. Can you see that there? Okay, so we've got all kinds of resources, and you can search here in the filter for your grade level. Let's say we want K, 2nd, 4th, 5th. Here we are, and we're going to search. And under that search, we did not get anything. Let's try that again. Well, apparently I should have tested this beforehand, huh? Well, let's just go to our tools for learning. And I just want to show you that we do have a TV timeline and other resources like this coming, where you can talk about the technology like the Jetsons, and like how the predictions of those future, what we thought might happen in the future, and how it was expressed in science fiction. Those are great language arts connections too. Man, I'm really sorry that my teaching resources was such a fail. I will double check that search for you. And I'd like you to just end with the reminder that AI for K-12 has great 5 big ideas for AI. And here is the graphic that they have downloadable and available at their website, aifork12.org. And I hope that you reach out if you need anything, and I hope this was valuable for you. Have a great day.